Coming to the Simulink, Simulink is for simulation and model based design environmental tool. It is used to create models of complex system using block diagrams. As we know, when we have created our model into the blocks, we can configure that models and we can do the manipulations for that blocks itself, so that whichever the block we want to tune or we want to do the modifications, we can do in the block levels also. And using Simulink, the models can be easily simulated and analyzed for better performance of the system. And coming to the Simulink, it is a practical way of approach by breaking the system into subsystem. Example, if you take in a system level, suppose one car is present. That car is a system level. Coming to the subsystem level, there will be like multiple subsystems will be present for this car. Like electrical wiring harness systems, and similarly this gearing mechanism, all those will be considered like a subsystems. Okay, so in the Simulink you can make subsystem levels and then we can integrate those into system level. It will be called as bottom to top approach, or otherwise we can use the top to bottom approach also. That means from the system level we can provide the inputs for the subsystems. Okay, we will see all those things in the lectures. And Simulink, it supports system level design and for the simulation of the model and for continuous test and verification of the embedded systems. That means we can provide multiple inputs according to our need, and then we can see how it will behave for those inputs. Suppose one system is there. For that system we are going to provide input and how the behavior of that output will be present. How that behavior of the output will be present, we can observe in the Simulink. And this behavior, when we are varying the input, we can check, suppose this input is a sinusoidal signal, then how the output will be changes at every point of time, like how we are observing in the CRO and all. Similarly, in the Simulink, there is a scope will be present. Using that scope, we can observe, like this is output. So for the scope, I will take with the two inputs. I will provide for output and input also. Then in this, it will be like using subplots we can plot, or using the single plot also you can draw the graph of this one. It will be automatically, it will draw. When you click on run, that means input we are providing and the output how it is coming, it will be plotted. Suppose if you are taken using subplot type of graph, then suppose this is an input, this is an output, means how that graph will look like. All those it will show. Suppose the graph is like a phase difference of 90 degrees. Then it will show that phase difference. Okay. These all things you can observe using scope module in Simulink. Like that, there will be like multiple of modules are present in the Simulink. Using those modules, you can generate our system and we can see its behavior. That is what we are going to discuss in the why to use Simulink. As Simulink is used to do the simulation of a complex system and analysis of data, and using Simulink, it is easy to model and simulate dynamic systems such as control systems and signal processing systems also you can simulate. And after generating the systems, while doing simulation, it will be easy for better understanding of the designed system behavior under different conditions. Okay, that means while transition is happening, how it is going to change. All those things you can observe and you can make informed decisions, and you can optimize our system designs based upon the performances which we have observed during the time of simulation. Okay, and another advantage is, key advantage of simulation in MATLAB is its ability to analyze data. As we know, this MATLAB is highly used for analyzing the data and synthesizing and visualizing all the data and all. We can pass the data from Simulink to MATLAB. Similarly, from MATLAB to Simulink also you can fetch the data. So this will be also one of the very key advantage. And its Simulink will provide wide range of tools for pre-processing and for processing and visualizing data. And as we know, these all are the applications mostly using by engineers and researchers. It will be highly useful for them. And another advantage is Simulink is a graphical modeling and simulation environment for dynamic systems. And let us get started with the Simulink. Before going to start, I just want to give one simple introduction for an example of one block. As I told, Simulink is a graphical modeling and simulation environment for dynamic systems. Suppose here one block I have taken. This is the amplifier block, or multiplier also you can call. So this is symbol for input. So the input we are going to provide it here. Suppose this is my input. Here it is amplifying the by value of 1. This is the block, and inside this block they have done the application of this one, that is 1 into that input signal. That one they are going to provide at the output. So as it is multiplied by 1, so it will be of similar amplitude. In case suppose, how easily we can change the parameters of this block. Suppose if you want to add any initial conditions, suppose initial value if you want to add, in this block parameters we can change the initial parameters. Similarly the timing parameters, suppose for some part of time you don't want to provide any inputs, then you can block that amount of time. And if you want to change this amplifying factor to suppose 10, then you can change to 10. Then in that case, suppose here the amplitude value is 1, then here the amplitude value will become 10. Okay, so like this, using a simple blocks, you can provide the inputs and outputs, and you can design the model of our required system, and you can simulate that one, and you can analyze its performance, and how to use those, all those things we can do using Simulink. Now we will directly go to the online MATLAB, and then we will see by taking some examples using Simulink.